Hey guys, so today's lesson's actually pretty short. I think it's actually pretty easy, but it is going to take some concentration and you have to pay attention, write things down, and I think you'll be okay. So it's called the change of base formula, this first thing that we're going to write down. In order to evaluate logarithms with other bases, you need to use the change of base formula, and that's what I've been talking about when I've been pointing out the button on the calculator, and I've mentioned how we're solving really by graphing two equations and finding out where they intersect right now. But now that we're going to go over change of base formula, we'll be able to solve our exponential equations much easier. So you're going to write this down. Change of base formula. Let A, B, and X be positive real numbers such that A does not equal 1 and B does not equal 1. Then, log base A of X can be converted to a different base as follows. Now, they put a little a down here. It really doesn't matter. I use a capital B. Another book might use a W. It really is an arbitrary letter representing a constant value. So, if you have something log base A of X, this is some constant. This can vary a variable. If we wanted to rewrite them with base B, what's B? B is just not A. Then we do log base B of X, whatever this is, divided by log base B, same base, of A, whatever that is. This is not to be confused with the quotient property. Quotient property would be something that looks more like log base B of a quotient, one log and a quotient next to it. Here we have the quotient of two logs. Base 10, same idea, but log base 10, or common log, doesn't require you to write anything over here or here. So we could just write log X over log A. So I always tell myself that the base goes in the basement, and then the other number that's here will go in the numerator. How about if we wanted to use log base E? Log base E is the natural log, so we would just write the ln of X over the ln of A. So make sure you write this down. Press pause if you need to, and when you're ready, we'll go on to the examples. Here are the examples. Evaluate the following logarithms. Here we have log base 4 of 25, and we want to evaluate this. Now, we can use any log base we want. For the first one, I'm going to use base 10, or the common log. And then for the last two, I'm going to use ln, or the natural log. I notice how some people write ln in their notes, and it looks more like a capital I-N, but I need you guys to make a mental note that that's a lowercase l and an n. It stands for natural log, and it comes from Latin, so the adjective comes after the noun. Here, I'm going to use the common log. That means when I punch this into the calculator, I will be writing log of 25, the main number, over log 4. I don't have a log base 4 button on the calculator, so I can't use that to get my answer. Change of base formula lets you use your calculator to get the answer. Here we have the calculator. I'm going to type this in now. If you have a fraction button, that might be helpful so you're sure of what's in your numerator and what's in your denominator. I really suggest you follow along with me. If you do this on your iPhone calculator, it will be a little bit more tricky. Log of 25. Here's the log button. 25. Close that parenthesis. I'm going to hit the down arrow, and now I'm going to type in log 4. Close that parenthesis, equals. There's my answer. It doesn't say where to round to, so let's go out 4 decimal places. So if I'm going out 4 decimal places, I'm rounding. If a question asks you for an exact answer, you have to leave it in terms of log. This is the exact solution. But if a problem lets you round, you'll use decimals and the calculator. Now I'm noticing that this calculator does have this button right over here. Let's compare the answer. Not every calculator has this, and also for word problems, it is going to be more practical to use something like a common log or an ln. But if I were to type this using this button, I have two fill in the blanks. I'm going to use my arrow to make sure my cursor is in the right place. The 4 will go there, and the 25 will go here. And we get the exact same answer. Now, let's do b. If we do b with the common log, or actually, now that I know that I have that button, I'm going to do b with base 3. If I want to use log base 3 of something over log base 3 of something. In my numerator will be the 12, and in the denominator we'll have the 2. These numbers don't reduce. This again is your exact answer, this whole entire rational expression. In the calculator, we'll type that log base 3 of 12 down here, log base 3 of 2. Here we have 4 decimal places. Where would we stop? If I ask you to round to 4 decimal places, you'll write 3 point what? 5, 8, 4. Now, I can't stop at 9 because the 6 turns the 9 into a 0. Since the 6 turns the 9 into a 0, it's really turning the 49 into a 50. If you're rounding out 4 decimal places, you must write 5, 8, 5, 0. You don't just stop at the 5. You include that 0 at the end. I'm going to throw in a little squiggly equal sign because it is an approximation. This one, we're going to do base e, or the natural log. How do I write this using change of base formula with base e? We would write this as the ln of 6 over the ln of 2. Again, that's not equal, I promise, to the ln of 3. Those are very different answers. We're going to type this one in the calculator. The ln button is usually an easy button to find on any calculator. That's why you'll see that we use ln most often. Ln of 6, ln of 2. 2.5849. So in this case, we also have that 6 turning the 9 to a 0, 5850. Interesting. And that's all it is. That's your change of base formula as a simple example. If you don't use the fraction button and you don't use parentheses, let's just see where things can go wrong. Log 25 divided by log 4. Do you see I got a completely different answer? 1.6183. That's not my actual answer for this problem. The reason it's wrong is because the 25 is being divided by the log 4 inside of parentheses. We'll get an answer, and then we're taking the log of that answer. That's why parentheses are important, and if you have fraction buttons, those can actually be very helpful. Here we have 4 practice problems. These 4 problems are for you to try on your own with your calculator. I've shown you in the past, in other lessons, in this unit, how to use your iPhone calculator. If that's what you're defaulting to, it is very different than using a regular calculator, so I definitely don't recommend it. I'm going to help you with the first one and show you how to do it on an iPhone calculator, and then you're going to do the next three on your own, and then I'll go over those answers with you. So make sure you're paying close attention. Rewind if you need to look at how I did it in the calculator again, or really stay focused if you're going to watch how I do it in the iPhone calculator. But keep in mind, in college or on a formal test of any sort, you're not allowed to use your phone calculator. Here we have log base 3 of 3.3. We're going to use a calculator to round to the nearest thousandth place. As a decimal, that place is tens, hundreds, thousands. So we need to go out 3 decimal places. When you use your phone calculator, you want it turned on its side so that you have all of the features. Now, the ln button is right over here. I'm going to use natural log for this question. Log base 3 of 3.3, I'll type in the ln of 3.3 divided by the ln of 3. Pay close attention. It's not as simple as you'd think all the time. If I'm typing this in, there's that ln button. First, I'm going to type in 3.3. Then I'll take the natural log of that number, divided by. I'll press 3, then I'll press the ln button. That means that it was the ln of 3. That is not your answer. That's just your denominator. Now I'm going to hit equals. My answer is 1.087 when I round. I didn't stop and write things down and round early. I left everything in the calculator until the very last step. Rewind and watch how I did this again if you need to. I'm going to use natural log for this question. Log base 3 of 3.3, I'll type in the ln of 3.3 divided by the ln of 3. Pay close attention. It's not as simple as you'd think all the time. If I'm typing this in, there's that ln button. First, I'm going to type in 3.3. Then I'll take the natural log of that number, divided by. I'll press 3, then I'll press the ln button. That means that it was the ln of 3. That is not your answer. That's just your denominator. Now I'm going to hit equals. My answer is 1.087 when I round. I didn't stop and write things down and round early. I left everything in the calculator until the very last step. Rewind and watch how I did this again if you need to. You're going to try these on your own. So go ahead and try number 2. The answer to number 2, when all is said and done, is 4.907. I hope you got that answer. Now you're going to try number 3 on your own. You should have gotten 1.161. Now we're going to try number 4. Go ahead and try it on your own. But before you do, let's just think about what the question is asking. 2 to what power is 2.1? And think about approximately how big that answer should be. You should have gotten 1.070. If you wrote down what you used when you did change of base formula, you should have something like what I have written. But since answers are going to vary, I'm not writing this down. You could have used ln, or you could have used common log, whatever button is more convenient on your calculator. Here we're about to begin our last 3 examples for today. In this example, we're solving an equation, and we've been doing these equations by using the log with whatever base we have in our problem that's being raised to the power with the variable. So if we were solving this by hand a few days ago, the way we would have gone about solving it is by taking the log base what of both sides. We would have used log base 5 on both sides. The log base we choose had been based, based on whatever number was being raised to a power with a variable in it. That number in this problem is 5. 5 to the 3x plus 7 and 3, 11. The next thing we did was log base 5 and 5 basically crossed out, and we were left with 3x plus 7. And on this side, we left it as log base 5 of 311. Subtract 7 from both sides because we're trying to get x alone. Log base 5 of 311, which is all one thing here, minus 7. We definitely don't need those brackets. I'm just showing you that we can't combine the 7 and 311. Last step, we divide everything by 3, and we have x alone now. So I can say that x equals something that looks like this. Maybe we write it without that bracket, or maybe we write it, instead of being over 3, with a 1/3 in front. And there's your answer. Now, we can put that in the calculator now because we know how to do change of base formula or use whatever button necessary. So if you put this in your calculator, what will you get? Well, we can look at it. Okay, so we're going to write in, because I have the fraction button, I have a pretty nice screen here, we can write everything in. 1 over 3, move the arrow over, parenthesis. Now, I do have the log base button, but I'm going to practice change of base formula. I'll use the ln button. 311 and 5 are the numbers, so I'll do another fraction button, ln 311, ln 5, minus 7, and close the parenthesis, equals, and our answer is -1. It didn't say where to round, so let's go out to 3 decimal places like the last set, -1.145. This was an exact answer, and this is an approximate solution. I am going to show us another way to do this problem before we move on. Another way to do this problem is with using just the natural log function on both sides. When you get to calculus, you tend to use the natural log function more often. There are many reasons for this. We'll elaborate another day. So if I take the ln of 3x plus 7 and the ln of 311, the next thing I could do is use the power property to bring 3x plus 7 out front. Now, I'm still trying to get x alone, so I'll do a little at a time. I'm not going to distribute ln 5. Instead, I'll divide by it. (3x plus 7 will equal the ln of 311 over the ln of 5. Again, please remember this is not the quotient property. I'll subtract 7. And now I multiply both sides by 1/3, and lo and behold, you will get the exact same answer we got before. Let's try the next one. Here we have another example. You're more than welcome to press pause and try this one on your own. If you tried it on your own, I hope you didn't take the ln of both sides. This one was a swap-opportunity. We could have rewritten both sides as 5 as the base. 5 to the second could have been swapped in for 25 to the 2x minus 1, and 5 to the third could be swapped in for 125 raised to the 3x plus 4. We're going to multiply our exponents. That gives us 5 to the 4x minus 2 equals 5 to the 9x plus 12. 5 to a power equals 5 to a power, therefore the powers must be equal. 4x minus 2 then must equal 9x plus 12. Subtract 4x from both sides. Negative 2 equals 5x plus 12. Subtract 12 from both sides. Now, I'm just going to bring the problem here. Negative 14 is equal to 5x. Don't just rely on me. Make sure you're able to calculate these things as well. And if not, make sure you're using a calculator when you're doing your assignments. Really, you should be weaning yourself off the calculator. X equals negative 14 over 5. Just leave your answer like that. No need to change to a decimal. If you use logs, you would have gotten the same answer. You're more than welcome to go ahead and try, but I think it would be silly. Now we have our last example, and this problem has an e in it. This looks like a step we would come across while we were doing a banking problem that had to do with continuously compounding interest. So this is just a little foreshadowing that we're going to be solving word problems using logs and ln's shortly. First thing I'm going to do is take the natural log of both sides. Here it's especially useful because we're dealing with an e anyway, and ln is log base e. Power property lets us bring the 4x minus 9 out front. The ln of e is really saying e to what power is e. What does that equal? That is 1, so we don't even have to write anything down. 4x minus 9 is equal to the natural log of 56. Add 9. And divide by 4. Now, type this in your calculator and check if you get the same answer I do. If you don't use parentheses correctly, you can probably find yourself getting the wrong answer. The answer should be 3.256. Actually, and again, a little squiggle equals. And that's all we have to do. Hopefully this all makes sense to you. It will take practice, but I just figure we'll do a few examples with change of base formula today, and we'll really elaborate on this in the next lesson.